Hi there, I'm Scott Lowe with Actual Tech Media, and thank you for joining us for this roadcast. I'm here today with Arjun Narang, who is product manager for Maxta. Arjun, thank you for having us here today.
Hey Scott, thanks for joining us.
So we're going to talk about resiliency and data protection and all this stuff, or just availability, what makes really IT tick.
Yeah.
You know, people don't like when things go down, and when companies like Maxta are developing really critical services on the data center side, you really have to think about all the potential failure modes that people could be encountering.
Right.
Tell us a little bit about what's happening in terms of resiliency and how Maxta handles things like that, because hardware can and will fail.
Yeah, definitely. And so, if you look at kind of traditional storage solutions, right, one of the keys for any IT administrator is when anything goes down, I can't lose my VMs, right? I can't have production impacted. And so now when it comes to hyperconvergence, you've kind of had this shift where before in the data center you had a separate compute stack and a separate storage stack. So if I had a compute failure, it didn't affect my storage, and same was vice versa. But now with hyperconvergence, everything running on the same server, you have to be able to tolerate a storage failure that also brings down your compute at the same time. So in order to handle that, you really need robust software that can handle a failure at any point in the stack, right? Whether it be a disk in your capacity or cold storage tier, whether it be an SSD that's being used as a cache device, whether it be an entire server, and even software failures, right? You don't want the storage service, the hyperconverged software, to fail and to bring down the entire server. You want that failure to potentially be contained and still have your guest VMs stay up without needing to migrate to different servers.
So how does Maxta look at the failure domain, basically? I mean, what do you look at individually? I mean, I assume you look at disks and all the other stuff, but what are the ways that systems can fail and Maxta can stay resilient?
Yeah, so that's a great question. So the way we look at it is, each component needs to be able to tolerate any single failure, right? So we start with sort of your capacity tier. So if a disk fails there, we maintain multiple copies of your data across the cluster. So if I have a disk on server 1 fail, Max will automatically redirect the I/O for all those guest VMs that were accessing that failed disk to the other disk in the cluster that has that data available. Similarly, if I have a server fail, right, you'll have HA kick in to migrate your VMs off that server, and then you'll also still have the data on the other servers in the cluster because of the replication we do. Now, kind of one of the interesting things is, what happens when one of my resource tier or cache devices fails, right? So in some solutions, this can actually cause your entire node to lose its storage capacity, right? But Maxta, in our software, we're able to do SSD mirroring. So on the cache tier itself, we'll mirror your write journal and your metadata and all of that across the SSD devices within a single server. So now if I fail a single SSD, I don't lose all that cache and metadata. I still have the copy on my mirrored device, and I continue running, just replace the failed SSD, and no real significant rebuild associated there.
So basically, there's a degradation, not necessarily even in performance, because you're on an SSD already.
Right.
And the worst case scenario there is the other SSD fails, but you would treat that as a node failure at that point, right?
Exactly. And when you have a node failure, right, we're going to, again, redirect those IOs to the other healthy servers in the cluster. And the other key here when we talk about the failures is, how do you handle the rebuild? Right? If I lose a disk, do I have to rebuild the entire set of data, or can I do incremental rebuilds and save some of that time that's spent where my production I/O might be affected?
Right.
And when you're talking about affecting production I/O, you also have to have kind of an adaptive system that detects how much incoming I/O is there from my guest VMs that are being used by my users, versus how much do I want to dedicate to the rebuild process. And so what Max has done in our software is we've enabled the ability to detect, how much incoming I/O is already on the cluster, and adaptively adjust how many resources we dedicate to the rebuild process. So that way we minimize the impact on the end users who are accessing their virtual desktops or doing builds for their dev environment, whatever it may be. They don't see that rebuild process affecting their performance.
What type of data protection is Maxta doing on the individual cluster, like inside a node? Are you doing RAID? Are you doing erasure coding? What?
Yeah, so within our software, we essentially do what amounts to a network RAID 10. So again, everything is done at the VM level with Maxta rather than doing sort of disk mirroring, right? We're going to take a VM's data, wide stripe it across multiple disks, across multiple servers also, and then we're going to create a replica copy. Now, the important thing here is, it's not like you have a primary and a secondary copy.
Right.
You actually have two primary copies, just whichever one responds first, Max will acknowledge back to the application for reads. For writes, we ensure that you have 2 synchronous copies.
Does the network RAID 10 impose any sort of write latency at all, or is this the Ethernet fast enough these days that it really doesn't?
Yeah, what we've seen is, if you're running on a 10 gig network, it's more than fast enough.
Right.
On 1 gig, yeah, you can, but today the bottleneck is not the network.
Right.
So you don't have any issues with that network RAID 10.
What about from on the rebuild side? You said you could manage exactly sort of how much priority is given to the rebuild.
Yeah.
And so you don't do in production impact, which is good.
Right.
How does that actually work? Like, is it user definable, or is it something the software does on its own?
Yeah. So there's 2 things, right? With Maxta, we really stress our application defined policies, our VM centric management, right? So one thing you can do is, say you have your mixed workload. You've got your production, your high priority SQL database, and maybe your print server. Mm-hmm. So on my SQL database, I can actually set a rebuild priority to be high, and on my print server, I can set it to be low, where Max will prioritize the rebuild task for the SQL server ahead of the print server, right? Then additionally, what I was talking about with the prioritizing your production I/O over the rebuild tasks in general, we do that automatically. Okay. So we kind of take away some of the traditional overhead that would have been associated with an IT admin, and allow the software to do it for you, intelligently.
So one of the things that we just talked about earlier was a node failure. And
yeah.
Basically you just kick off HA and move the VMs. That's the only time you'd even see a blip. I mean, because you've got to reboot the VM at that point, right? Because you're not doing lockstep fault tolerance, right? And that's pretty good for most organizations.
Yeah. And then, beyond that too, you're going to have the data protection with snapshots. You're going to have sort of stronger checksums where if there is, even bit rot or a misdirected write, we're able to detect that because we do the checksums at both the metadata level and the data level. So in that way, you're alleviated from any issues that would arise with a misdirected write.
Got it.
So there's again, the whole idea is every layer of the file system, or of that entire virtualization stack, you want to be able to tolerate the failure. And like you said, with HA you'll have a reboot, but every other instance, you're not going to see any effect, to any of your VMs there.
The only thing you might see is performance degradation because by design.
Right.
And that's actually user configurable.
Right.
So that the organization determines if you're going to see that or not, which is really the way you want it.
Yeah, exactly. Yeah.
Excellent. Arjun, thank you so much for that explanation. Really appreciate it.
Thanks, Scott.
And thank you for joining us for this video.